بالعكس جدا سعيدة بحضورك، جدا سعيدة بمعرفة حضرتك.
والله أنا
لأن الشرف إنه نتعرف بحضراتكم وناس بهالمستوى هذا، إنه جاي يساهمون ويلقون محاضرات وطلبتنا يستفادون من عندهم.
الله
وبس
يسلمك.
طلبتنا حتى إحنا من جاي نحضر أكيد نستفاد من حضراتكم. شكرا جزيلا.
هو الفائدة متبادلة، يعني هلا نحن ما وصلنا لشيء الكمال، يعني كمال لله. دائما كل يوم في تعليم، دائما كل يوم في شغلات جديدة، فإن شاء الله تعالى. Shall we start?
Okay, ثواني بس المقدمة. Welcome to all attendants in a new lecture presented by Boston University for Oil and Gas Student Chapter. The title of the lecture is Wireline Technology and Well Intervention, presented to you by Mr. Samer Shukri, who has 25 years of experience in industry with 7 years in management. He also worked as workover supervisor, well services team leader, senior production engineer, senior well integrity engineer, senior petroleum engineer, international oil and gas trainer from UK, and he is also accredited IWCF well intervention instructor from Aberdeen, Scotland. Welcome, Mr. Samer.
Thank you very much.
I hope you're doing fine.
Thank you very much. I hope that everybody will enjoy our lecture for today, which is about the wireline technology and well intervention. It is introduced and sponsored by Basra University for Oil and Gas SPE Student Chapter. Today is 25th of May 2021. I will just a quick look. I will introduce myself. My name is Samer Shukri. I studied petroleum engineering in Syria in 1990 till 1995. My nationality is Turkish. I have experience since 1995 up to date. I worked in these fields from workover to well services, production, well integrity, all of these, and worked for several companies. Like this, started with Syrian Petroleum Company, then moved to Al Furat Petroleum Company, which is a joint venture between Syrian Petroleum Company and Shell. And I studied also in Holland and got certificates from Shell Company in Rijswijk in Holland. Then I moved to ADCO. I worked there in this field, BAB or Habshan field, which is in the red circle. Then I moved to training. I am international oil and gas trainer from Scotland, Aberdeen, and also I deliver courses for International Well Control Forum, IWCF, in level 2, 3, and 4. These are my certificates for training. Also, if you want, I have a YouTube channel. You can take benefit of it. I put all my lectures there, and you can watch them, do subscription, do like. Also, you can see me on LinkedIn, the same name, Facebook also. I also always I put videos, put something useful for you. Also, this is my email and mobile. Here, my positions. This is a quick look at my profile. Then we will go through our lecture for today. We start with agenda, then introduction, well life cycle, introduction to International Well Control Forum, and certificate with exam, well control calculations, well types, completion, principle, classification and types, in addition to components, wellhead and production stage, gas lift system. So it is very rich. Today's lecture is very rich. So if you understand it, you will understand a big percentage of oil industry. So we'll go through them: a reservoir monitoring plan, well intervention principle, which is our main objective, well intervention methods, and we will go through three types of them: wire, slick line, braided line, and E-line. Then wireline proper handling, rig up of wireline, standard wireline tool string, wireline barriers, and so on. We'll talk about the tools, what can we run in the well, common applications of slick line, wireline operations before moving coil tubing, fishing operations. This is very important and interesting operations. So if you can start understanding the principles of the wireline first, then you will see the fishing is very interesting subject. So after that, I will discuss a study case for slick line fishing, then a braided line uses, advantages and disadvantages, E-line applications, which has three main applications: perforation, logging, and water shutoff. For logging, we have open hole logs and cased hole logs. We will take an example of logging, which is noise log. Pressure control equipment for only these three types of well intervention: slick line, braided line, and E-line. Wireline barrier, we will talk about the principle of barrier and what types of barriers: primary, secondary, and tertiary. We will take a case study for stuck cable or tools. At the end, we'll take the personal protective equipment and question and answers. I put about 6 slides, or about 15 to 20 questions and answers that come in the IWCF exam. So if you know the principle, the lecture, and the aim of the lecture, then you will answer these questions very easily. After that, I am guaranteed that you will take the IWCF very easily. So after you graduate from the university, you have to go to the field or to the offices. Some companies, they refuse to hire you unless you have this certificate. So many companies refuse to hire you unless you have it. So you have to study very well, and you are willing, I think, with your study in the university, and you are willing to take extra. Now I give you, you can consider it extra because you have workload, and this workload, this is additional. So when you have free time, then you can take this and watch it. Even if you are not here now, after that we will put it on the YouTube, and you can watch it from time to time. Today you can watch 30 minutes, tomorrow 30 minutes, and so on. So, and you can repeat it day by day. So, and you can take notes, you can write, you can watch the videos. All of these, at the end, your knowledge should be high, because there is a huge competition with others, and the companies cannot take all graduates from the university. So, for example, if 100 engineers are graduated this year, the 150 engineers will find a job this year. And maybe next year, 25 engineers will find a job the next year, then the last year. So why don't you find a job quickly? If you build yourself, if you build your knowledge, I am guaranteed that you will gain, and it is all related to money. So money, time is money. And money is time. Where does this money come? It comes from the knowledge. We are engineers, so we have to improve our knowledge and the way of thinking. So if you don't do that, you will miss your opportunity to be the first to join the oil companies. I am talking worldwide. It may be in Iraq, it may be in Emirates, in Qatar, everywhere. So if you have your mind and your knowledge, I am sure that you will find your excellent and very good opportunity. Let's move on to our introduction, an oil well. What is oil well? Oil well is any boring through the earth surface that is designed to find and acquire liquid hydrocarbons. We have hydrocarbons below the surface level by 3,000 meters or 10,000 feet. So how can we retrieve it? How can we extract it from the downhole? We have to drill a well. This well is called oil well or gas well or water well for water injector or whatever. So it is a hole. We drill, then run casing, then behind the casing we do cement, surface stage, then intermediate stage, then production stage, then run the completion. All of these we have to do them and work on the well very safely and avoid any incident that could affect on the company's reputation. It can affect on the financial issues, on the human lives, on the equipment, on everything. So we have to take care. We are working in a very dangerous environment. If you don't know the principles and procedures to work, you will do mistakes. You may lose the lives of others or may lose your job at the end. So it is not easy to work. We have two types of wells. We have exploratory well and the production well. For exploratory well, we drill a well, one or two or three wells in an area that is not discovered before. This is called exploration drilling. It depends on the seismic data or satellite survey. Then when we discover the oil and do our studies, our calculations, how much initial oil in a place, what is there, oil, gas, water, condensate, all of these. So after that, we start to extend our drilling. We may drill 100 wells. You have in Iraq huge fields also, like Kurna field. You have what else? In Kirkuk also, it is from the biggest fields in the world. Also many fields that can be developed. So after exploration, you have to develop this field and drill extra more wells that you can retrieve or produce this oil and gas during, for example, 30 or 40 or 50 years plus minus. In this case, you are working professionally and you plan production for each well. Wireline history. Today we will talk about wireline. Wireline, it has slick line, braided line, and electric line. I think most of you have seen this wireline track for Schlumberger, but we don't know when did it start. Mechanical slick line was formerly known as a measuring line. It was in 1927. Two French brothers from Schlumberger family, they are considered as the inventors of electric logging in 1927. This one, about 92 years ago, 94 years ago. This wireline unit was, but today's wireline unit it is like this. So a huge difference during 100 or 90 years. Here is the wireline unit. We have the Christmas tree. We talked about this one, how to drill it. Then we at the surface we installed the Christmas tree, lower master valve, upper master valve, flowing valve, killwing valve, swap valve, and here we have these riser, wireline BOP. We have T-piece. This is a lubricator and stuffing box. So this is the rig up for slickline. Wireline rig up, this is standard. And here we have wireline unit. Here we have hay pulley. Here we have also the wheel of the stuffing box. And the wireline is run in the hole and pulled out of the hole. And here we have the power bar. We'll talk about these in detail, one by one, piece by piece, operation by operation. Here we have subsurface safety valve for safety. And here we have a hydraulic control panel to operate the BOP, which is the secondary barrier. Here we have 3 barriers: primary barrier, which is stuffing box; secondary barrier, which is BOP; and the tertiary barrier, which is upper master valve, that can cut the wire in case of primary and secondary barriers have failed. Here, if we have a quick look at the well life cycle, we will start with the drilling of the well, then run completion. I mentioned that for you. Then production. This production may extend 20, 30 years plus minus. Then intervention. We will talk about this one. Intervention today. Then the well is not, when it is not producing anything, it will be plugged and abandoned. Or in different words, we can say the drilling is design, completion is construct, or production. So these are similar to these words: design, then construct, then operate, then maintain. Maintain means intervention, then abandon. Here you see well construction, it includes drilling and completion, then production, then maintenance. We have this maintenance. Well intervention. Well intervention, we have 9 methods. Today we will study 3 methods of them. So workover is part of the well intervention methods, and the lifetime extension. We can extend the lifetime of the well as maximum as we can. Then plug and abandonment. Here I will just tell you something about the well control. This certificate, I deliver courses for it. So in the future, you are mandatory to get this certificate if you want to work. We have 2 types, drilling and well intervention. I will tell you about well intervention. You have to study these 2 subjects are mandatory: completion equipment and completion operation. Then if you want to work wireline, operator or supervisor, you have to do exam with wireline. So this 1 plus 2 are mandatory. This is optional. If you want to work in coil tubing, this is optional also. So it will be, if you want only coil tubing, then you will do exam this one, and this one. If you want a wireline coil tubing, you will do 4 exams. For snubbing, it is hydraulic workover. It is rarely used. In 1992, it was used, yes, but during the last 20 years, the number of snubbing units, hydraulic workovers, this number has dropped, and today it is used only, I think, in Algeria, in our region. So we have 4 levels: familiarization or introduction. This is this level 2. This you can do it by yourself. If you want, you can watch my lecture on YouTube about well intervention. If you write well intervention, well control, you will see the all details. How can you get this level 1 for this IWCF? It is free. You don't pay anything. Just you do the exam by yourself, and you will take from Scotland. They send you the certificate. After that, you will be ready to move to the second level, which is level 2, then level 3 for operators, then level 4. We will talk now about wireline operations. Let us move this video.
Like many operations in the oil and gas service industry, wireline operations is a 24-hour-a-day job. Crews may work long hours in any type of weather to respond to customer needs. Wireline operations usually involve lowering and retrieving specialized equipment into the well, some for testing and some for plugging off zones in the well. Here, a 3-man crew from Long Car Services shows us how a slick wireline is set up. First, by installing the blowout preventer on top of the well.
This is lubricator. This is the stick line.
Then the wireline equipment is assembled on the ground and the wire is threaded. Some can hold over 2,000 pounds and reach depths of 30,000 feet. After the string is together, a crane lifts the unit into place where it's secured to the top of the wellhead.
You see, this is the rig of the equipment.
Once the pressure is bled, the wellhead is opened and the wire line is run into the well. At this site near Caroline, they're actually using slick wireline to retrieve tools that have become stuck deep inside the well during another company's service work. Slick wireline operators are sometimes part detective and part fisherman, since they have to figure out how to grab something they cannot see nearly 3 kilometers below the surface of the earth. They're resourceful people who can think on their feet, and they're a vital part of the petroleum services industry.
So this is just to give you an idea about the rig up of the wireline. You saw each part. We'll talk about it in details. This one, the calculation, well control calculations, you have to memorize it. Always I deliver it, and I ask the attendees just to memorize it as if your name. It is very easy. It is very simple. You can memorize it over your lifetime. So it is very easy. We can do the hydrostatic pressure equals to vertical depth times density times constant. Also, all of these, if you have any question, you can ask about it. Bottom hole pressure equals hydrostatic pressure plus closed-in tubing head pressure, and so on. So all of these, also specific gravity, pressure gradient, time to pump, and this one. So it is easy, and you can have a look at it and memorize it. Now we can move to the types of the wells. We talked about this one, exploration or production for the type of the well. Also, we have, as per geometry of the well, it may be vertical, horizontal, or deviated. I will show you now the well schematic of each type of this one. Well types, as per the production phase, we may drill a well to produce an oil. It will be called oil producer. If we want to produce gas, it will be gas producer. If we want to inject water, it will be water injector, or gas injector, or WAG, water alternative gas injector, maybe water supply well, water disposal well. So each type has its own function, and we use it for a special function. Here the completion, after drilling the well, we run the completion, and we want to produce maybe from different zones. We isolate the upper two zones and produce from the lower one, or produce from the middle zone and isolate the upper and lower, and so on. So you have a strategy to produce from this well, and you need the completion to be suitable for this one. Sometimes you run a single completion, sometimes you run a dual completion, sometimes you run single selective, single completion. So I will show you these ones. We will talk about also completion components and accessories that are used in each completion. You see, we have these types. This is type open hole completion. It is not cased here, not cemented, not perforated. The second one is cased hole and perforated. This one, open hole completion. This one, cased perforated completion. This one. Here, multi-zone completion. This one, single. This is or dual. Dual, we have short string. We produce from this zone. This one, we have sliding side door here, and we produce from lower zone. So long string, this is called long string, and this is called short string. Here we have the completion types: single completion, single selective completion. I will show you now these types. And dual completion, dual selective completion. Look at it here, please. Single vertical completion. This one, single vertical. Here, single selective completion. We may produce from this. So 3 zones. We isolate this one, and produce from here only. Or from all of them, or from 2, or from the upper and close the middle and lower, as per the production strategy over 30 years or 20 years. Here we have dual injector. We inject here gas and water. One to inject the water zone, one completion, and the other completion is to inject gas. Here we have a single slim hole. We don't have same as here. You see here we have Packer, SSD, gas lift mandrel, subsurface safety valve, all of these. Here when we have this formation that we don't want to put any obstruction in front of the hydrocarbons to be produced to the surface. In this case, we put it like this, as if pipe, just pipe. In this case, we produce from the well. In this case, we use it when the reservoir pressure is not too high. So we know what is here, and in this case, we make the well produce very easily. Here we have single completion. This is vertical, single selective, vertical. The other type is horizontal. You see, we drill to here, then we open a window in the reservoir, then we may drill 600 feet or 1,000 feet or more, plus minus. Here also we produce, but vertically. We have also deviated. You see, it could be 70 degrees. Now 90 degrees. It could be 70 degrees like this, or it could be like this. So deviated between them. Here is the typical completion that is run in the well from the top, which is a tubing hanger that holds the weight of the completion till the wireline entry guide. We can see here the wellhead, the Christmas tree. After that, the tubing head spool here. Then we have the completion. We have subsurface safety valve. You see it, downhole safety valve. We have a side pocket mandrel. We have also sliding sleeves. We talk about them. I will give you an idea, short description about each one, because if I tell you we set the plug in the nipple, you tell me what is this nipple? I don't hear about it. Explain about it to me. So I will give you in advance, but not in detail. We will go into details for our subject, which is the well intervention and wireline. Landing nipples, also we set the plug here in the landing nipple. You see it here and here. Also packers, packer will isolate the casing from the reservoir. Because if you keep the casing is exposed to the well pressure and temperature to corrosion, to all of these, then it will be corroded, eroded, damaged. While if you lose your completion, if it is damaged or cut or pinhole or plugged completely, then you can move work over. It is a type of well intervention methods. You can run, kill the well and pull the completion, run another completion and finish. It is very easy and cheap, not that expensive. If you want to drill a new well, the cost will be more than 10 times. Then perforated pop joint, you see it here. We'll talk about them here also in details. It may be more clear, more details. This is from bottom. This is wireline entry guide, this one, and to the wellhead. The previous one is from the top, from the wellhead to the bottom. So, but same components. You can see them. Tubing hanger, as I told you, when we run the completion, we hang this tubing using the tubing hanger. And here we have tie down bolts. We can isolate also the tubing from the annulus. So the annulus is isolated and no hydrocarbons will be getting into the annulus, or pressure or temperature. Here subsurface safety valve, when we have any emergency or any unplanned issues like fire, like explosion, like this, then the subsurface safety valve will be closed automatically. There is ESD system and it is connected to the surface safety valve, which is upper master valve, hydraulic actuated, and subsurface safety valve. When we have any problem, fire, like explosion like this, then it will be closed and shut the well automatically without causing any problem. So this is we call it subsurface safety valve. We have two types, self-controlled and subsurface controlled. With wireline, we have to check this subsurface safety valve. It could be wireline retrievable or tubing retrievable. For subsurface safety valve, we have two types also, ambient pressure and differential pressure. This is run with wireline. This tubing retrievable safety valve is run with the tubing with completion, and the other one, wireline retrievable subsurface safety valve, is run with wireline. We have to do maintenance for this subsurface safety valve wireline every 12 to 24 months. While for tubing retrievable subsurface safety valve, we don't do it. Just exercise, open and close the subsurface safety valve. It may stay in the hole for 20 years or 30 years. As it is working, no problem. This is the downhole safety valve. We talked about wireline retrievable and tubing retrievable. You see it here. We have a flapper, and this flapper is pushed down. You see, it can open like this. This is from up to down. So the flapper, when the fluid is pushing, the fluid is coming from here to up. So the flow tube is pushing this flapper. As it is open, the well will flow. You see, this is the flapper is open. This is the flapper. If you see it, I see it, red one. It is open. This one is open. Flapper is open. Safety valve is open. The flapper is closed like this. The safety valve is closed. And this is the flapper. We call it downhole safety valve, self-control subsurface safety valve, self-safety valve, tubing retrieval. So different names for the same item of the completion or accessory. Production tubing, when we run the completion, this is the main item which is called the tubing. It may be 2 and 3/8 inch, 2 and 7/8 inch, 3.5 inch, 4.5 inch, 5 inch. 5 inch and more, it is called then casing. Below 5 inch, it is called completion or tubing. And we have couplings between them. You see, this is J55, the green one. The red one is C75. Each one has different color. So there is a black one, there is a gray. Those the colors are higher grades. This tubing may be damaged. You see this damage, it is exploded, or there is a pressure from inside very much than the outside. In this case, there is a rupture in the tubing here, or mechanical damage. The packer, we talked about the packer. It isolates the tubing from the casing, and these fluids can be produced to the surface without contacting with the casing. In this case, the casing will stay in the well forever without any damage, because the fluid from the well, it has high pressure, high temperature, CO2, H2S, all of these. We may also do acid stimulation. So if the acid is contacting with the casing, what will happen? The casing will be damaged, and in this case, we will be in trouble, and we will lose our well and drill another well. Here, landing nipples, where if we want to isolate any zone, we can set a plug in this one, and we have 3 types of nipples: no-go nipple, selective nipple, and safety valve nipple. Circulation devices, we have 2 types: sliding side door and side pocket mandrel. We can see them. This is side pocket mandrel. This is a sliding side door. This one, SSD. All of these, we have internal sleeve. You see it here. This sleeve has holes. When these holes are opposite to these holes, like this case, then the sliding side door will be open. If the holes are not opposite to each other, like this one, then the SSD will be closed. In this case, when it is open, we can do circulation from the annulus to the tubing, or from the tubing to the annulus. You see it, it is called circulation device. The other type is called side pocket mandrel. Also, it is run with the completion. We set here either circulation valve or gas lift valve or dummy valve, or chemical injection valve, or a dump kill valve. We have different types of gas lift valves. So if we will talk about gas lift system, but you have to take an idea about what is this side pocket mandrel, what is this gas lift valve. We set it and pull it using a tool with Wireline. It is called kick-over tool. This one, it has two series, OM 1, 2, 3, 4, 5, and OK 1, 2, 3, 4, 5. So two series, and the sizes 1 inch and 1.5 inch of these valves. But now you take an idea about them. In the future, you will know what I am talking about. If we expect that there is a turbulent flow from the well, we have two types of flow. You know them, laminar and turbulent. Laminar, like this, like a line. Turbulent, it will be like this. In this case, turbulent, what will cause to the completion, to the tubing, it will make erosion for it. This erosion, how can we protect it? For example, if you have landing nipple, this one, then you have to install flow coupling upstream of it and downstream of it. Otherwise, if you have low turbulence, in this case, you install just downstream. This is called downstream. Downstream after the landing nipple or the completion accessory component. So this is called downstream, and this is called upstream. So flow coupling upstream and flow coupling downstream. This is called blast joint. For the coupling, it is used just to reduce the erosion for the completion accessories, and it has a same OD of the completion, but the ID is less. Why? Because there is wall thickness more than the wall thickness of the tubing. In this case, as it is eroded, it will not affect because we have extra wall thickness of this flow coupling. Also, when we expect that there will be erosion from the outside, if we have this perforation, you see it, and we have to produce from it to from the reservoir to here, we have SSD here, or here SSD. So in this case, the flow will hit or hydrocarbons will hit this area in the completion. If it is not holding this erosion, it will be eroded, and the completion in this case will be replaced. So what shall we do? We have to install, this is called blast joint. It has the same ID of the completion, but the OD is bigger because the erosion is expected from the outside, not from the inside. Flow coupling from the inside, blast joint from the outside. In this case, what will happen? We protect this area. It could be 30 feet, 50 feet maximum. So in this case, as erosion is available, so we will keep our completion in a healthy condition. Flow coupling, polished bore receptacle. Sometimes we produce hot fluids, hydrocarbons. It will make the completion to expand. So when you heat up the completion, it is a metal. What will happen? This completion length will increase. If it increases, there should be something here to contain this increase or excess length of the completion. We use it polished bore receptacle. Here we have a male and female. We can seal on the outside of it, and here seal on the inside of it. It moves like this inside it, move up and down, but there should be, you see it like this. It should be like this within upstroke and downstroke, but not like this. If it is like this, it will get out of the female. In this case, we need workover. and if it goes too much inside, what will happen? There will be unset of the packer. There will be more pressure on the packer. It will unset. In this case, we have to calculate it. The space out should be as reasonable as possible. It could be 20 feet. We could put it on the middle stroke or bottom stroke or upper stroke. Upper stroke, if we expect high temperature in the lower stroke, if we expect low temperature, if we inject cold water, in this case, the metal of the tubing will shrink, will contract. If it contracts, what will happen? This piece, you see it, will move up, but within a limit, 20 or 30 feet, not more than that. So we can contain this piece inside, mail inside here, and move. We have another type, tubing seal bore receptacle. You see the male, the piece with the completion is called female, this one, while with the packer, it is called male, this one. So different designs, but I explained to you the main function of these tools. Wireline entry guide, when we run wireline tool or coil tubing, we have to retrieve it easily without cutting the wireline. We have two types, bell guide, this one, and the mule shoe. Wellhead also, you see it, Christmas tree. We have these valves, API flames. We connect them to each other. And we have this type, monobore wellhead or Christmas tree. This is conventional. And here, we have the whole wellhead. This is the the surface casing, intermediate casing, and production casing. And this is the casing head spool. You see, this is the monobore Christmas tree, and this one we are working. Production stage. This is the most important stage in the well life cycle. We produce the well for 20 years or 30 years or 10 years as we want from our target. Here, a gas lift valve, we inject gas from the annulus and produce the well from the tubing. You see it from this one. In this case, why do we use it? Because the well is not producing naturally. If it doesn't produce naturally, what will happen? The well will quit. It will not produce. So we inject gas from here, then produce, then the gas will move here and up, then move here up, and there will be offloading of the reservoir. You see, this is gas injection. It will reduce the hydrostatic head on the reservoir, and it will make the production easy. Here, the gas lift valves, dummy valve, and gas lift valve. We have 5 types of the gas lift valves. Here, we put it in the side pocket mandrel, this one. Reservoir monitoring, we do reservoir pressure monitoring for the reservoir over the life cycle of the well. We have different types of the surveys, bottom hole closed in pressure, bottom hole flowing pressure. This is for oil producer and water injector. This is bottom hole flowing pressure for oil producer. This is pressure for survey for water injector, PBU for oil producer, interference test for both, integrity test for always, capacity test for oil producer, modified isochronal test for gas wells. This we can interpret it and how much is the reservoir pressure. Here, modified isochronal test. This is actual survey, and the result is this. We can produce at gas well at 25% of maximum production then close it, then 50%, then close it, then 75%, then close it, then open at 100% of production capacity, then close it. So we have time 12 hours flowing, then 12 hours shutting, then 12 hours, 12 hours, 12 hours, 12 hours. Here we produce this at maximum production for 24 hours and close it for 48 hours. This is called modified isochronal test for gas wells. We may, if we don't want to close the well, if we have here this well, active well, if we close it to do a survey, what will happen? The well will quit. It has high water tap. In this case, what can we do? We have to avoid closing it. We have a nearby well. This well is far 300 meters away from this well. So, but they are producing from the same reservoir. In this case, we can take the same reservoir pressure here and here. You see, this is called observer well or observation well. And this well can be continue producing, but in the meantime, we can measure the reservoir pressure. Well intervention. Now, all of these, what we talked about was an introduction. In well intervention, it is the fourth stage of the well life cycle. If you remember, just now we mentioned it. So what are the main operations that are carried out on the well during well intervention operations? We have 9 operations. Here I give you just a quick review. In the next slide, I will talk in more detail. We have Wireline. It was invented in 1927, and it has 3 types: slick line, braided line, and electric line. Then we have a new technology called electric line tractor. This is used in high deviated wells and horizontal wells. Coil tubing, it was invented in 1962. Hydraulic workover, long time ago, but now it is rarely used, and workover. This is the summary. But if we go into details, we will find 9 operations. We start from pumping. Pumping is the simplest form of intervention. If we want to pump corrosion inhibitor, we pump diesel, we pump fresh water into the well, we can bullhead or do killing of the well, we do pumping. Or they rig up on the killing valve and pump from this well. Then wellhead and Christmas tree maintenance. From time to time, we have PM maintenance, we call it. Periodically maintenance for subsurface safety valve. Sometimes we have a plan to test it, grease, every 6 months or every year. We have subsurface safety valve, upper master valve, surface equipment, all of these, killing valve, swab valve, all of these we have to do maintenance for them. In this case, this is called a well intervention method. The third type is slick line that we will talk about it. This slick line operation is slick line operation may be used for fishing, gauge cutter, setting and retrieving plugs, deploying or moving wireline retrievable valves and memory logging. It is very big subject. You cannot imagine any well in our oil industry except it needs this slick line. So it is 100% mandatory in each well. You will see now what we are talking about. The fourth type of well intervention will be braided line. This braided line is used in two cases. if we want to fish the stuck tool string, sometimes we get stuck tool string and wireline. In this case, what will happen? The maximum pulling tension for slick line, say 2,000 pounds, but this one, it may take to 10,000 pounds. So in this case, this is used for fishing. Also used for swabbing. If there is a dead well, if you want to produce the well without this nitrogen lifting or coil tubing or like this, if you want, you are sure that the well will produce by swabbing like pulling. You put a tool inside the tubing, a very big tool, and you pull it very fast. In this pulling, the well will produce, and the killing fluid in the well will be produced out. Coil tubing, also, if you have a vertical horizontal well, the wireline will not go to it. If you have a deviated well more than 70 degrees, then the wireline will not work in it. Any case like this one, you need coil tubing. If you need to pump acid to the reservoir, especially directly to the reservoir, the wireline cannot be used. What will happen here? You have to run coil tubing, and this coil tubing you can pump in it acid, mud acid. You can pump kill fluid. So it has a very wide range. This coil tubing, you can know more about it. I gave a lecture about it. If you check it in my YouTube channel, it is very interesting subject. The snubbing, we talked about it. It is hydraulic workover. When we need to run the completion tubing under pressure, the well has a pressure, and we force this completion inside the tubing. This is called hydraulic workover. It can force the string of pipe into the well against the well pressure to perform the required tasks. This is more complicated than coil tubing. Coil tubing is simple if it is compared with this one. Then the workover. Workover, this is costly. Screen. The screen, you see it? Zulfaqar, I see resume. Resume sharing. Yes, now it is okay. I pressed something. I don't know. I will continue here. Yes. Workover, here in some older wells, we need to change the reservoir from the bottom to the upper. In this case, we have to isolate it, pump cement, or set a bridge plug, and above it we have to set 3 meters of cement. In this case, we have to perforate, we do stimulation, we run a new completion, different design of the well. In this case, we need workover. We have also here the subsea well intervention. This is for offshore operation. It is more complicated, more complex than onshore operations. Here you see it. This is the slick line. This is the slick line. This is this one. This is the braided line, and this is the electric line, this one. So slick line is this one. A braided line is this one, and electric line is this one. Here we have conductor. It can send the electric power from the surface to the downhole and do logging, do perforation, do set the bridge plug, and like this. For this one braided line, we can fish the stuck wire line with tool string or do swabbing. For this one slick line, we will do about 20 functions. We will mention them one by one. You see, these are the three. This is slick line. It has two main ODs, 0.108, 0.108, and 0.125. So two OD. Here, braided line, the main OD is 7/32 or 3/16. You see, and we have two types, conventional and diform. Diform has more strength than conventional. And electric line, we have monoconductor and multi-conductor. Here, this is a brass, and we can send electrical signal. Here, stick line, wire line. We have this one. We have ODs, these two, 0.108 and 0.125. We have two types, carbon steel and stainless steel. Carbon steel has higher tension pulling than the stainless steel. But stainless steel can work in soil gas wells, these ones. Here also, it has better than this because the OD is bigger, 0.108 and 0.125 inch. This is the slick line. About the braided line, we have these the two sizes, nominal 7/32 or 6/32, which is a 3/16. We have two types, conventional and diform. Breaking strain is this, and breaking strain is this. You see, for diform, it has a bigger or higher breaking strain. Here, diform considerably stronger. The other size is 5/16 inch. Also, it has like this. We have electric line. This is the nominal diameter, and this one also the types like this. Now we can go to slick line. Slick line, we can use it for fishing, gauge cutter, setting and removing, all of these. Slick line is very simple. It needs only 2 or 3 persons to move, rig up, run in hole, pressure test, do all of these without any complexity. It has two nominal sizes, 0.108 and 0.125 inch OD. And it is made of carbon steel or stainless steel. Carbon steel is stronger, but it cannot work with the H2S more than 30 ppm part per million. If you have H2S percentage 30 ppm and more, in this case you need stainless steel that is corrosion resistant for H2S. In this case, but the tensile strength will be less than that for carbon steel. And it can be run in oil wells, oil producer, gas producer, water injector, gas. So all of these wells can be used with this slick line, and we can run wireline tools. So the wireline tools, which slick line, it is called a piano line or solid line or measuring line. This is for slick line. So the same, this slick line, we call it piano line or solid line, wire line, or measuring line. And we have two types, as we mentioned, carbon steel and stainless steel. Carbon steel has advantages that it has high tensile strength, as I told you now. It has low cost. If you go to stainless steel, it is expensive. We have also good ductility and can be used in sweet wells and with H2S up to 30 ppm. After that, you need to use stainless steel. This is stainless steel. Stainless steel is used in sour wells, but it is weaker than carbon steel. There are different types of stainless steel. We have SOPA 70, 75, and 80. Stainless steel is corrosion resistant. Wireline, proper handling to reduce bending stresses. How can we make this wireline safe and we can utilize it for maximum period of time? We have to follow the following steps. We have first to reduce the fatigue and bending stresses on the wire by making a proper connection with the rope socket with the wireline on the drum. The second one, we do lubricant especially when we first run in hole, we put the grease on the wire so its movement across the stuffing box will be easy and simple to avoid and reduce the friction. We can, from time to time, every time we can cut 50 feet of wire line and make a new rope socket. Also, when jarring operation, it is advised to stop for short time because this wire will heat up. If it heats up, it will be broken easily after that. So we stop for 20 or 30 minutes, make it cool down. After that, we continue. We may need also to move the wireline track. If we do jar up for 30 minutes, in this case, the same area, pull out, jar up, down, then jar up, down, then jar up, or the opposite. In this case, what will happen? There will be weak point in this area. If we latch the plug and we cannot move up or down, what will happen? There will be weak point. In this case, we can move the wire line, a track maybe 2 or 3 meters right or left. In this case, we change the weak point of the wire line. Also, spooling of the wire, it comes on a big drum. When we want to spool it on the drum of the wireline unit, we spool it in this way. This is the correct. This is incorrect. Here also avoid kinking of the wireline by different ways. You can move the wireline to the string in this way, or do some rig up like this. It will make weak point in the wire. Also avoid the wire from contacting with metal. The wire line is contacting with the stuffing box packing only. This is rubber. So in this case, it should be suitable, this packing. And it will be greased, and there will be lubricant. And there will be no weak point here. Stuffing box hay pulley also. This is the stuffing box where the wire line is coming from down, then up, then down. Here it will go to here. This is the hay pulley. Should be having OD in 2 cases. If we have slick line, this OD it should be 120 times of the wire line OD. If we have a braided line, we should have the OD of this sheave or hay pulley. We can use it 64 times braided line OD. This is a rod. We talk about wireline rig up. We see it or not? This is for Al-Mansouri, different rig up. It is interesting. Let's watch it. This is in Abu Dhabi, I think. They do safety meeting, then rig up. This is the BOP. This is the stuffing box and the haybury. Riser. They do pressure test, and this is chart. Lubricator sections, quick union. This is the haybury, stuffing box, rope socket. Gauge cutter. This is the rope socket. This is the rig up on the wellhead. I worked with this screw, I think. Open the swap valve. Take the zero, then run in hole. This is wireline operator. This is the drum. Hay pulley. This is on the rig counter of the wireline. Run in hole. Martin Decker for weight. Run in hole. Here is the safety valve, subsurface safety valve. Stop. Then latch, pull out of hole. He is retrieving the subsurface safety valve. Here is gauge cutter first, just to locate the safety valve. Al-Mansouri. The video is finished. I think it is interesting. Let's move on to the next slide. Yes. Now we can move to the advantages of using wireline over coil tubing. Wireline is easy to move and transport within 1 hour. They can move, re-up, pressure test, and start running hole. 2 or 3 persons, you saw them, 3 persons can do all of this, and safely and very easily. Also the cost, it has a very low cost. The crew member, coil tubing needs maybe 7 or sometimes 10 or more persons to operate the package, while here 2 or 3 persons only. The disadvantages of wireline over coil tubing, here we have low yield strength if compared with coil tubing. The maximum tension that you can apply here maybe 2,000 pounds, while with coil tubing you may apply 40,000 pounds or 50,000 pounds. So big difference. Cannot do rotation using wireline. With wireline, you cannot do rotation or do pumping through it, while with coil tubing, you can do that. Also, cannot do circulation using wireline. The other issue, you cannot work in high deviated ways more and horizontal ways. High deviated ways more than 70 degrees and horizontal ways also. So this is the rig up. We have, you see, we'll talk it. We have from the drum here to the measuring device, then hay pulley, then stuffing box, then lubricator, then BOP, then we run through the Christmas tree to the well. We have here bending events, one here, then two before the measuring device, three, then hay pulley, 4, 5, then the stuffing box, 6, 7. So these we call them bending events. So 7 in run in hole and 7 in pull out of hole. So 14, the number. Bending cycles, we have these ones, we mentioned them. The same events when pulling wire line out of the hole. So 7 run in hole during run in hole and 7 during pull out of hole. These we call them 14 events, bending events. For bending cycles, we have 7. That is just in run in hole. You see it, hay pulley angle. When we this is the hay pulley angle. When we have it like this, 90 degree, what will happen? The reading on the counter will be accurate. But if this angle is less than 90 degree, then the reading will be more than the real reading. This 90 degree, say 80 degree. So if it is like this, it will give more reading. The third case, if it is more than 90 degree, if it is like this and like this, it will give less reading in the depth. In the tool string, we have the following items. Rope socket, we saw it, that is connecting wire line with tool string. Stem bar, also wire line, that gives weight to the wire line tool string. We have 2 or 3 or 5 feet. Mechanical jar, it acts as if a hammer. This hammer that is making the action, hammer up or hammer down. Wire line knuckle joint. This, if we have deviated well or we need more flexibility for the tool string, in this case, we run it between the sections of the tool string, wireline tool string. Wireline, at the end, we have wireline running or pulling tool for running and retrieving devices from the wellbore. We have different running tools and different pulling tools, different fishing tools, plugs, all of these, we can use them. All wireline tools are available in the have connections or threads, 3 types of threads. Saccharode threads, we'll see the photos for them now. UN threads and quick lock connection. You see them? This is the standard wireline tool string, rope socket, stem, mechanical jar, knuckle joint, and the tool. Here is the rig up. This is the slick line rig up, and this is the E-line rig up. You see this one. Here is the drum sheave, and here stuffing box, hay pulley, then lubricator, BOP, Christmas tree. Here barriers, we have 3 types of barriers for wireline. We have a primary barrier, secondary barrier, and tertiary barrier. This is pressure control equipment. For a primary barrier, for slick line is the stuffing box. We saw it. The secondary barrier is BOP, and tertiary barrier is hydraulically operated upper master valve. For braided line and electric line, we have a primary barrier is called grease injection head. Secondary barrier BOP, and tertiary barrier shell seal BOP. You see it, this one and this one. Here, this is the primary barrier, and here the secondary barrier BOP. Tertiary barrier is the upper master valve. Here is the Stamberger truck platform express. This is and there will be crane to hang this pressure control equipment at surface. It has a height plus minus 38 feet. Here we have examples of barriers. We have stuffing box. This is the primary barrier. We have secondary barrier BOP. This is wire slick line BOP, not braided line, slick line. And here a grease injection head for braided line and the electric line. You see, a wireline operation can be carried out on live wells and dead wells. In live wells and dead wells, in this case, we should have minimum 3 tested and verified barriers. Here, the unions or threads that we talked about them just now, we have wireline tools connections, thread types. We have Saccharod threads, these ones, like this one. We have UN threads, these ones, and a quick union for wellhead equipment. Quick union, we have Bowen and Otis. Bowen, you see it, the sealing area is 90 degree, while Otis type, it has 45 degree. You see, this is between the lubricator sections. The tools that can be run in the well during this wireline operation, we can mention the following: Baker C1 running tool, B shifting tool. This is for setting and pulling, for setting the plugs. This is for open and close SSD sliding side door. This is type CMD. This is the different type of sliding side door. We need another shifting tool. It is called D2 shifting tool for DU SSD. GS pulling tool for setting and pulling subsurface safety valve. We have GDC Camco pulling tool, RB pulling tool, different types, impression block, magnets, fishing tools. We have Godeville, wire grab, wire finder. Here we have stuffing box packing, this one. We have Baker V packing, this one. Different, we have a spear, internal fishing neck. We have a blind box if we want to cut the wire. Gauge cutter just to drift the well. Knuckle joint for deviated wells. Swaging tool if we have damage in the tubing we want to fix it, we run this swaging tool. Sample baler, if we want to take a sample from the bottom hole, either fluid or solid or sand or scale, we can run it and take sample. Stem, this is the stem bar. It gives weight for the tool string of the wire line. Quick connection, this one you see, quick connection. This is a thread, and this is quick connection. Diamond broach or wire brush. If we want to brush R nipple or F nipple or SSD, there is a scale inside it. In this case, we can run this brush. Wax knife also, we can cut the wax. It is like a solid oil depositing on the internal side of the completion and the completion components. In this case, we can cut this wax and retrieve and continue the production with the same rate before this obstruction in the way, which is wax, heavy oil depositing on the internal side of the tubing. Tubing and locator, if we want to locate the last end or the bottom end of the tubing, we run this tubing and locator with wireline, and we run it below the wireline entry guide. When we pull it here, this will stop it. If it stops, what will happen? The tension will increase. If it increases, then we pull very fast. In this case, when we pull very fast, this will be broken, and we know that at this depth we have the wireline entry guide. We have a tubing brush. We put wire here or braided line and do brush, same as this. Also we do brush. Wedge, also rope socket. This is the internal side of the rope socket. We put the wire like this, and we take it from the other side, this one, and the other side will go down. Here is the workshop of the wireline. These are the most wireline tools that are run in the way. This is wireline workshop. The most common here we have the most common applications for slick line are we can mention tag TD, gauge cutter, just to make check the accessibility or if there is any collapse in the tubing. What else? We have also baling, sand, debris from the plug or from the downhole, open and close SSD sleeves, setting and pulling plugs and chokes, setting and pulling gas lift valve. So different about 20 or 30 functions, running tailpipe even also. Also we can do bottom hole pressure and temperature surveys. We mentioned that before. The bottom hole closing pressure, bottom hole flowing pressure, pressure fall off survey, modified isochronal test. So we can run the memory gauge and do these surveys for 1 day or for 20 days or sometimes for 2 months. So it depends on the period that the program requires that. Spinner surveys also, we have a spinner to know what is producing from this zone, what is producing from this zone. So we can say that this zone is producing water, this zone is producing oil, this zone is producing gas, and so on. This is called PLT TDT. PLT is the abbreviation for production logging tool, and TDT is the abbreviation of thermal decay time. It is a tool, and we can do these are geophysics surveys. Kinley perforator, also we can make a punch in the tubing using it. Sand line cutter, also if we have sand, we can run the cutter and remove this sand and let it produce to the surface. We can do a run caliper also to make sure that the integrity of the completion is okay. There is no lack of integrity. The tubing wall thickness is okay. So this is the caliper. Running production logging tools. Also, we can do gamma ray, CCL, logging tool, noise log. All of these we have. We are coming now to the types of the logging tools: open hole logs and cased hole logs. We will do them. Also, we have fishing operations. If we have stuck tools, we can do fishing, paraffin, wax, scale cutting, shipping ice, lubricating long assemblies, bottom hole sampling, detonating, perforating guns. So all of these, we cannot say that we do a small job on this. We have too many. Variability. The operation is very variable, and we can take much benefit of it. Detect the fluid level if we have gas, oil, and water. So how can you do it? We run the blind box. and at the interference between gas and oil, the weight will drop suddenly. Why? Because there is a buoyancy factor for the oil more than the gas. In this case, the weight will drop dramatically. Also, if you are in the oil, running in the oil, and you face the oil water fluid level, in this case, also the weight of the tool string will drop. Why? Because the buoyancy factor of the water is higher than the oil, and so on. So we can utilize it and see why is the well dead. What is the reason why, if you want to kill a well, you want to take this data also. Sometimes you have pieces of metal at the bottom of the well. It fell down for some reason. We don't know. So we have to run the magnet and retrieve it. Either a small piece or big piece or whatever, we have to deal with it. Set and pull subsurface safety valve for routine redress. For wireline retrieval subsurface safety valve, normally we need every 12 months or 24 months to retrieve it and set it again. Or before we run the coil tubing. If we want to do well intervention, we want to do stimulation like this, we have wireline retrieval subsurface safety valve. In this case, what do we need? We want to retrieve this wireline retrieval subsurface safety valve, then reset it again after the coil tubing operation. For the fishing, we have here, if we usually refers to attempting to retrieve lost tools or wire or other debris. So this is the fishing operation. It is very interesting, very fantastic. You can see that when you fish something from the well tool string or wire, that you feel yourself very happy. It happened many times with us, and it will happen in the future. So as you have intervention to the well, in this case, you will need to find fishing for some reason, because nothing is perfect. Sometimes from the well, sometimes from the crew, sometimes from the equipment, sometimes from the wireline. If the wireline has a micro corrosion inside it, you cannot see it. You do your job as per procedures. But if you have anything uncontrolled, what can you do? It is come. Then you have to plan to fish this wire, and you can retrieve it. It is not a very difficult operation. There is a procedure. You can do it, and maybe on a daily basis. This happens in every place in the world. So don't worry about it. You are dealing with a dangerous environment, and you have to deal with it professionally and with less risk. Braided line, we said that it is for fishing, stuck wireline to string, and for swabbing. Normal size is a 3/16 inch. These are types for braided line: conventional and diaphragm. Advantages: it has more. It is made of synthetic solid materials and can make more tension than stick line. Also, we can say that many braided lines are very difficult to break. It is not easy to break, same as stick line. Braided line can also be have a longer reel life, because we don't use it continuously. We use stick line continuously, but for this one, we can use it from time to time. Maybe during 1 month, you use it 1 week, not more than that. So it is more strong, and we can more solid. Disadvantages of these: braided line. One disadvantage is when snagged, it sometimes becomes very difficult to break. If it latches the tool string of the wire line and you cannot retrieve it, what will happen? Disengagement is not easy at all. So you have to consider this one. Also, braided line is generally more expensive. Also, braided line may not be the best choice for fishing clear water. It is not used in the clear water in general. If backlash, the braided line can sometimes be very difficult to untangle. Most braid lines require much sharper instruments to cut it because it is thick, big size, 7/32. So you need more. You use shear seal BOP to cut it because upper master valve cannot cut it. Electric line, you have logging, do it, perforation, and water shutoff. Wireline logging, we have two types of wireline logs: open hole logs and cased hole logs. We need some of you, just anyone has any experience in the logging, just to tell us what are the types of the logging that are used. Yes, tell me. We want to take a break for 2 minutes, and you can tell us these are the types of open hole and cased hole.
Okay,
Yes,
anyone has the answer can raise a hand.
These are here. You can just look at them, and if you have any idea, you can read them only. Yes, Mr. Abdul Fakar, go ahead.
لا الدكتور ما يصير اشارك انا.
No problem.
لا ما يصير ما يصير.
You are one of us. No problem.
لا اخذ دور المحايد.
No problem. Open hole logs. What are the types? Tell me.
عندنا احنا النيوترون والدنسيتي
resistivity
عندنا والاس بي والكاليبر.
Yes. So a nuclear log, nuclear magnetic resistance. So you can memorize these, write them in your book. I think it will be very useful for you for the future. Then mud logging, sonic logging, then specialty logs. This is the open hole caliber that you talked about it. Casing collar locator, casing inspection, borehole imaging, downhole magnetic surveys. We can go to cased hole logs, which is a temperature log, radioactive tracer log, noise log, diverting spinner flow meter, continuous and full bore spinner flow meters. We can take an example of the logs, which is noise log. Noise log, if we want to see where is the leak coming from behind the intermediate casing, or from the production casing, or from the surface casing, from casing to casing, or from casing to annulus, or from annulus to tubing. So this noise log will give us an idea about it, and it will determine what is going on. It needs 2 days for making it. First day, we take the background in the well. The second day, we can do the main job and identify the flow path to be determined using the noise. You see it here. We have here the leak from here to here. In this case, there will be sound. The sound we will hear it with this with this tool, logging tool. Here we have perforation. If we want to perforate the well, we have these perforations. You see them. We can run it and use the electric line. And here after the perforation. We have three types of perforation through casing perforation. This one, you see it with the rig on site. We have it through tubing perforation. We have the tubing here, and we run it through it. And here we have it through tubing conveyed perforation. We can shoot and drop or keep it with us to the surface. So three types of perforation. Also, this is the pressure control equipment while perforation on the wellhead and pressure control equipment during perforation. Slick line pressure control equipment, we can see them here. We can see a stuffing box, chemical injection sub. You see them. Then hydraulic tool catcher, lubricator sections. We have hydraulic tool trap if required, quick test sub, wireline BOPs with the blind drums, riser and pump in T, and Christmas tree adapter or crossover. This is for slick line. For braided line, we have some minor change in it. We can mention them. Hydraulic packing nut or stuffing box at the top, then below it there is line wiper, then grease injection head, the flow tubes, then hydraulic tool catcher, lubricator sections, hydraulic tool catcher, if required. This is, we mentioned it here, quick test sub. This is a tool trap, we call it hydraulic tool trap here, if required. Quick test sub, dual braided line BOP, riser. We have this riser, then shear seal BOP, then pump in T or sub, then Christmas tree crossover. This one also we repeated the standard wireline equipment result. Here this is for the braided line. This is for the wireline pressure control equipment for wireline and braided line on electric line, of course. This is the stuffing box. We run the wire from here, the hay pulley, to here. We have a nut here, and here we pump hydraulic oil. To here there is piston, then a spring, then upper bushing, and it can push on the packing. 3 or 4 packing elements around the wire and can achieve the seal and run in hole to the wireline. Here we have chemical injection sub if we want to pump chemicals, pump lubricant, pump we can pump also chemicals for dehydration. If we have hydrates, we can pump methanol or glycol. So all of these through the chemical injection sub. We have a hydraulic tool catcher. If the tool is the wireline operator is pulling the tool string fast to the surface, then the wire may cut because he has to pull out a hole slowly. So if it is cut, then it will not drop in the well. Why? Because this hydraulic tool catcher will catch it. You see these are the risers, lubricator, 2 or 3 pieces of riser. It is called lubricator. It should have a bigger ID than the most OD of the tool string. It should have a length enough to contain the tool string of the wire line, and the lower section should have a bigger size than the upper sections to contain the tool string that is run on the wireline tool string. You see, this is we call it the hydraulic tool trap. The tool string is going up, then it will not go down. Even if it is, if the wire line is cut, it will not drop down the hole. Quick test sub, if we do different runs in the well, for example, perforation. In this case, we don't do the same pressure test every time. What will happen? We do only in the beginning for the whole pressure control equipment, then the runs that are later to be run later, we do the test from this one only, between two O-rings. If it is okay, then we can continue, especially if we have perforation. If we have perforation, what will happen? If we increase the pressure in the lubricator, the guns may fire. In this case, you will be in trouble. Here are the wireline valves or VO. This is dual and this is single. We have the rams. You see them here, the rams. If you close it, you have to close it hydraulically first, then manual. This one. And it has a blind. Look at me like this. You see, the wire is included in this rubber. Rubber is here and rubber is here. If you see it here, there is rubber and here is the rubber. It is a blind like this. Here is the single wireline BOP, and here are the pieces of it. Here is the ram inner seal. You see blind, and here is the guide. So if we change this wireline BOP from this to braided line, we have to change these two pieces, ram guide and ram inner seal, because with braided line there should be here like a groove, because the cable is big, while here it is blind. Here we have pump in T. Sometimes we need to pressure test the lubricator or to kill the well. In this case, we we rig up the pump in T or sub. We have a wellhead adapter also. These are planes and adapter to connect the pressure control equipment with this to the wellhead and to the pressure control equipment. Braided line and stuffing box. We have it suitable to use with the braided line and providing a partial seal around during the applications, such as swabbing. So this we have it different than the slick line. It has it is a braided line. So even if you apply pressure on it, it will not hold the pressure. There should be grease around it. How we can do that? Using the grease injection head. We'll go to it. You see, this is the grease injection head. At the top, you have a stuffing box. Below it, you have this line wiper. You see the line wiper. And below it, you have here the grease injection head. We pump the grease from here, the bottom flow tube, and we retrieve it, circulate it from the upper one, the upper connection. So hydraulic line wiper is this one. Any grease is still in the wire line, it will not get out. It will go to the return drum or grease drum. So here we can achieve this one, the seal around the cable, using the pressure that is pumped here and retrieve it here, receive it here. So as if circulation here in and out, and the pressure should be 110% of the wellhead pressure. So if you have wellhead pressure 1000 psi, you have to pump here 1100 psi degrees, and you will achieve your C. Here, working pressure for this line wiper, we mentioned it 3000 and 5000 psi. Here, the grease injection head, as we told you, it is grease injection is injected from the bottom, and we receive it from the top. And the clearance between the braided line and the OD braided line or electric line and ID of the flow tube, here are the flow tubes, 3 or 4 or 5 or 6 pieces of a flow line. It will make the grease injection head. So if we pump here and we retrieve the grease from here, what will happen in this case? What will happen? Yes, we pump grease from here, and it will be the waste will be to the drum here. Okay. Here we connect the hand pump to the stuffing box here, and we have also here is the flow tube, and here is the cable. The clearance between them is between 0.002 to 0.008 inch. So very small clearance. So if you pump here, it will not take during the whole operation maybe 1 liter or 2 liters, not more than that. In this case, you achieve your seal around the cable and work safely. You see it here also, check valve, this ball, if the wire, the cable is cut and ejected out of the grease injection head, what will happen? There will be no well fluids getting out of the stuffing box of the grease injection head, because this ball will be pushed up due to the wellhead pressure and plug this flow passage. This green one will move to here and close it and secure the one. This is called ball check valve. While in the stuffing box of the wireline, we call it wireline BOP plunger. So that one, if we, I will show you what is this wireline BOP plunger. The reasons for braided line grease seal leak. Sometimes the grease is not working very well, so we have different reasons. This is more detail. If I think you don't need it, but if you want to look at it, it is here. To prevent the leaking from grease injection head, you have to run in-hole slowly and increase the grease injection pressure to 110% of wellhead closing pressure. We mentioned that also. Help the grease to flow into the well rather than out of it. Pass a well-greased section of wire through the flow tube. Here is the wireline BOP for braided line. You see, we have this is single barrier. This is called single barrier. It is dual. If we want to do a double barrier, it will be 4 rounds. Okay, 4 rounds. So here, this one, normally, the BOPs are holding pressure from the direction of flow. What does it mean, direction of flow? Where is the direction of flow? From the bottom to up. In this case, this ram, you see it, will, if you close it around the wire, it will prevent the flow from bottom to up, this one. While this one, it is inverted. This is normal, this is inverted. If it is closed, in this case, it will not hold the pressure because it is holding the grease pressure, not the well pressure. Because here we have injection point for the grease. This injection point for the grease, what will happen? The grease will go up and go down. Go down, it will push this ram around the cable, but not the well pressure will act this seal, only the grease. And here also the grease will push it up and make the seal. It is clear, I think, for you. Here the same photo for the dual BOP, you see it. Here is normal ram, here is inverted ram. So here we have to inject the grease between them. You see grease injection port here, and we can do the seal. If this is dual braided line BOP, if you want double, you have to put 2 plus 2, so 4. This is 4. Then the rams, what is the shape of the ram? It will be from the top, it will be normal, inverted, normal, inverted. So 4 rams. This is very important. And here is the top sub, here is the bottom sub. Here we passed now 2 hours. I will stop after this slide, and I think you became tired, and more than 2 hours it will not be okay. So triple BOP here, we may have dual BOP 2 rams, or triple BOP 3 rams, or double BOP, which is 4 rams. Normal, inverted, normal, inverted. So 4 rams. Here is the shear seal BOP. This is the tertiary barrier, because if the primary barrier, which is a grease injection head, and BOP, which is the secondary the secondary barrier, failed, what will happen? We have to go to the tertiary barrier, which is shear seal BOP. Here the rams, you see this ram as if knife. It will cut the cable and make the seal. You see it? It is very clear for you. In this case, you can make a seal and secure the well, because the primary barrier has failed, secondary barrier has failed. What can you do? Go to the tertiary barrier. Here is also the typical wireline rig-up for pressure control equipment. Here we mentioned it. What else? BOP pressure test. If we want to do pressure test to check the integrity of oil joints in the BOP stack, BOP seals and valves. We have to clear. We can use the function test, open and close, and then pressure test. If we have wireline, we can blind. We do the blind. If we have braided line, we put test bar and close it and inject grease between the 2 rams and see if there is any leak. This test of the BOP should be done in 2 cases. When we want to start an operation, and the other one when we suspect a leak. In this case, we send this BOP to the workshop and bring a new and tested one and do pressure test and function test before rigging up, before running in hole. And in this case, we are making sure that we have certified and tested barrier, and the testing should not exceed 21 days. Here also we have two tests, low pressure and high pressure. Low pressure, if we have to do it between 250 and 350 psi for 5 minutes. For high pressure, we do it 110% of wellhead close in a pressure for 10 minutes. Why? Because low pressure test, if we have the pin and box of the test of the lubricator is damaged, this pin and box, and we go straight away to the high pressure. In this case, the O-ring, what will happen? It will prevent us from knowing that there is a leak here. So we stop at 250 for 5 minutes. If it is okay, then go to high pressure. And here is the pressure test of Wireline BOP. We do the pressure test body. It depends on the working pressure, if it is 5,000 or 10,000, 15,000, 20,000. We have criteria. This is API criteria. Grease required to close the BOP. I think it is now. We finished 2 hours. Mr. Dud Fakar, if you want to continue, I think you became tired.
Thank you, Mr. Samer. I think now we can get questions from the audience.
Yes.
If anyone has a question, can raise a hand.
Anyone has written any question in the system here or not? Okay, no problem. I think we can.
I think there is no question because it was a very clear lecture. Thank you, Mr. Samer, for the great knowledge. And I think now we're gonna end the lecture. Thank you for your time with us.
Thank you.
Thank you.
Thank you very much. Good luck. Thank you.